or that are wrapping around the histones. And again, if this model was true, the authors believed it would be true because transcription factors would be able to come in by this transcription start site and allow transcription to occur, while they would not be able to do the same thing on the sections of the DNA wrapped around the histones. So, to test which of these models was correct, they again employed primer extension, but this time they performed a digestion with a restriction endonuclease, XBA1, which was known to be about 10 base pairs downstream of the Kruppel promoter. And after digestion with XBA1, they found that some of the DNA was cut and linearized, while some of the DNA was not, due to interference from the nucleosome. I like to think of it like a string representing DNA, wrapped around a tennis ball representing the histones. The string can't be cut when wrapped around the tennis ball because there isn't enough room for the scissors to cover the depth of the string. Similarly, the XBA1 restriction sites can't be cut when DNA is wrapped around the histones. After digestion with XBA1, the DNA that was not cut, which is the DNA with promoters that wrap around the histones, was subjected to in vitro transcription analysis with primer extension. Because the only DNA being tested after digestion was the DNA that had been protected from XBA1 digestion with the histones, any significant amount of Kruppel primer extension product observed would indicate that transcription had occurred at the start sites wrapped around the histones, which would support the first model. In this scenario, full-length Kruppel mRNA would be produced, and the radiolabeled primer would be able to bind or hybridize to that mRNA, and reverse transcriptase would be able to extend your primer, and you would get DNA that could be detected on a gel. On the other hand, if no primer extension product was observed, it would indicate that the start sites wrapped around the histones were 0% active. In this situation, no primer extension product would be created because there would be no mRNA to bind or to hybridize with your primer. So reverse transcriptase wouldn't be able to synthesize DNA, and there would be nothing to detect. This would support the second model. Through this experiment, they found that there was no transcription of XBA1 resistant DNA, since there was no primer extension product, supporting hypothesis number 2, in which transcription occurs at maximal efficiency in the regions in between the nucleosomes, while transcription of DNA wrapped around the histones by RNA polymerase II is completely blocked by core histones. In summary, Katanaga's group successfully demonstrated the repressive effect of the core histones alone on in vitro transcription with RNA polymerase II, and showed that genes with promoters wrapped around histones are unable to be transcribed. This is all I have for now. If you are interested in more in-depth explanations, feel free to peruse my references, which you can see here. Thank you for watching. I hope this video has helped you understand the experiments showing the role of core histones in repression of transcription. Have a wonderful day.